Number 10. Consider the system shown in figure 16.9. What is the change in entropy for the process where the energy is initially associated only with particle A, but in the final state, the energy is distributed between two different particles? Okay, so we're talking about change in entropy, right? A change in entropy, randomness of molecules, that's a delta S value. So we're looking for a delta S, and they're talking about distributions here, and they give us this figure 16.9. So when we're talking about state changes and probability values with the delta S, there's only one formula that comes to mind, and it's this formula right here. Delta S equals K times the ln of WF divided by WI. Now, the delta S is that entropy change, right? That's what we're looking for. So we should know basically everything else over here. Well, K is a constant value. It's the Boltzmann constant. It's 1.38 times 10 to the negative 23rd. And this is in joules per Kelvin. Your W values have no units. So whatever the Boltzmann constant is, which is joules per Kelvin, that's going to be the units of your change in entropy, joule per Kelvin. Well, now what is a W, right? Well, the W is always your number of microstates. Basically, microstates are like scenarios, right? Each one of these is represented as a microstate or a scenario. We just have to figure out how many microstates or scenarios is in the final thing that they told about, divided by the initial. So let's just write it out. We're solving for delta S. So this has to equal the Boltzmann constant, 1.38, times 10 to the negative 23rd. And now this is ln times something divided by something else. Let's do the initial first. Now they did say that initially we were associated only with particle A. So we're looking for those microstates, or, the scenarios in which we only had the energy with only particle A. Do you see how in all of these, there's 4 letters, A, B, C, and D. We only want that energy, and the star in this case is the energy. So for example, for this one, and for all of them, there's 2 stars. That's the energy. We only want these stars to be associated with only particle A. Let's see. Well, this one for sure, right? Those stars are only going to A. So that one checks out. This one, no, right? This one's only B. This one's A and C. A and D, B and C, B and D, all C, C and D, and all D. So initial, we only have one microstate or one scenario. So 1 goes on the denominator. Now we got to find out what's going on with the final. Well, in the final state, the energy is distributed between 2 different particles. Now, they did not specifically say what particles. They did not specifically say whether we wanted AB, BC, CD, or AD, right? We just need to have it for 2 different particles. So let's see. This one, most certainly. This one is between A and B. Can't be this one. That's all B. This one's good. That's A and C. That's 2 different particles. This one's cool. That's A and D. This one's cool. 2 different particles, B and C. Same thing for this one, B and D. This one can't. That's just C. This one, totally, C and D. And this one, no, that one's all D. So there's 6 total blues over here. So my final is just going to be 6. Now let's just plug in and solve for our change in entropy. I'm going to do this all in one shot. If you need to take the ln of 6 and then times it, go for it. But let's see if we get the same answer. 1.38 times 10 to the negative 23rd. Cool. And I guess we'll take 3 sig figs. So 2.47 times 10 to the negative 23rd and joule per Kelvin. And in this case, the delta S is a positive value. Whenever you have a delta S that's positive, that means that you're becoming more random. And it makes sense. You started off with only 1 possibility and you ended with 6. So the more possibilities, the more microstates, you're going to be a positive entropy change, more randomness. And there you go. I hope this helped you out. Let me know in the comments. Subscribe to the channel. And I will be talking to you in future lessons. I hope this is helping. Check the channel out. We got physics and math videos and much more subjects coming your way. Thank you so much for the support. And I'll see you soon. Okay, bye.